Okay, example number 16 asks us to express x minus 43 over the quantity 2x plus 5 times the quantity x minus 4 in partial fractions. So it wants us to take this fraction here and split it into two. Well, we learned earlier from different methods that let's say we had two fractions, something like this. Well, what would happen is, in order to get our final answer, or our sum, is you would multiply down, you would use our sign in the middle, you would multiply up, and you would divide by the denominators multiplied by each other. So we can use this kind of in reverse to figure out, okay, how is it that we break this into partial fractions? Well, your denominator is going to be the product of the denominators of the split up fractions. So if we know how to break our single denominator into factors, we can break that up. And based off of that, we know that there's going to be a combination. So one of our denominators, b, over on this side, is going to be multiplied by some sort of factor of the other side, and so on and so forth. So we end up with this kind of crossover combination. So using this algorithm that we have, we can break this fraction up and figure out how to write this as 2. So the first thing that we are going to know here is that based off that logic, right, each of these two factors is going to be its own in our partial fractions. We know that this is going to occur because of the way that everything worked. Now, we're going to have some number times this, x minus 4, some number times this is going to goes right here. All right, it adds in. We're going to call this a, capital A. Then this multiplies by some other number, which will be some capital B. Notice that it's going to be a degree smaller here. And that together is going to make this x minus 43. So what in a sense we have is sum a times x minus 4 plus sum b times 2x plus 5 equals our x minus 43, which is what we have. So our goal is to try to figure out what the a and b values are here. So what we do in order to figure this out is we're going to use the idea of the b over a. Now, our b over a comes from our form of the ax minus b that we've been working with for a while. So basically, what number creates a 0 for this expression? What number creates a 0 for this expression, and so on. So what's going to happen is that's going to allow us to eliminate one of these variables and move on. So let's say for our first one here, okay? So 2x plus 5. So our b value is going to be negative 5 halves. So what we're going to do is we're going to plug negative 5 halves into x. So we're going to get a times negative 5 halves minus 4 plus b times 2 times negative 5 halves plus 5 equals negative 5 halves minus 43. Okay, well, the goal of that is that because if we plug in negative 5 halves, this becomes 0. This whole thing here zeroes out. And so we're just going to be left with this part. So this is going to be a times, so negative 5 halves minus 4 is going to be negative 13 halves. And negative 5 halves minus 43, so that'd be 86 halves. So this would be negative 91 halves. And then we would end up saying that a is going to equal negative 91 halves divided by negative 13 halves, which is going to give us 91 over 13, which should equal 7. So a gives us 7. So that number is going to be true. And that is, again, because we picked our 0 to 0 out our b based off of this denominator right here. Now, to go to our other denominator, we're going to pick the number 4. Because since x minus 4 is multiplying by a, if we plug 4 in for x, it'll 0 a out and allow us to solve for b. So we're going to get a times 4 minus 4 plus b times 2 times 4 plus 5 equals 4 minus 43. And we solve for b. So this becomes 0. This is 8 plus 5, so this is 13b equals negative 39. So we're going to get b to equal negative 3. So all in all, what we're going to have here is our a value, which is 7. So we're going to have 7 over 2x plus 5 plus negative 3, which we can change this to a minus 3 if we want. It works the same way, over x minus 4. That is the same thing as what we had to begin with, which was x minus 43 over 2x plus 5 times x minus 4. So this is our expression listed in as partial fractions. So we're using the idea of kind of the crossover method to deconstruct a composite fraction, one that's been already added together, and break it apart again.